Our webinar. My name is Teresa Rapasso Subang with WSP Canada, and our topic today is how climate change and resilience can be incorporated into human and ecological risk assessments. Next slide. Our presentation will provide an overview of trends in climate change and how human and ecological health risk assessments can be expanded and used to build resilience in infrastructure to mitigate against projected climate impacts. By considering climate trends and including high-intensity events in health and ecological risk assessments, infrastructure can continue to function in the face of changing climate risks. We will provide an overview of assessment tools that add value to your projects and answer questions that stakeholders may be asking. The webinar handout is in our handout box, and there will be a question period at the end of the presentation. And so we invite you to send your questions in the questions box of your GoToWebinar control panel during the presentation. Next slide. Just to give you a bit of a background, I am a senior technical lead in toxicology and risk assessment with WSP Canada, based in Ontario. I have several accreditation with Harvard School of Public Health on risk assessment and risk communication, American Board of Toxicology, United Kingdom, and European Registry of Toxicology. During my 30 years of experience, I've completed human and ecological risk assessments for infrastructure projects related to mining, oil and gas, transportation, and waste, nuclear projects. I also served as a technical expert in regulatory and public hearings. Next slide. I have the pleasure of co-presenting with Sean Capstick, who is an expert in environment and social governance and climate change. Sean has 30 years of experience, and he is a principal with Golder, a member of WSP Canada. Sean has extensive climate change experience in several sectors, including mining, industry, transportation, buildings, waste, and nuclear. Sean has conducted training on behalf of Engineers Canada and has developed Mining Association of Canada's climate guidance. He is also a member of the External Advisory Board for Canadian Climate Services. Next slide. Our climate is changing. This slide presents the annual reported number of natural disasters categorized by type and includes both weather and non-weather related disasters from 1970 through to 2019. Around the globe, we are experiencing increasing frequencies of extreme weather and flooding, with parts of the globe experiencing extreme temperature, droughts, and increased frequency of wildfire. Next slide. The changing climate impacts our natural resources, our forests worldwide. This slide illustrates forest loss from 2001 to 2019, shown as pink on the figure, with the primary causes related to land development as well as climate change. Loss of forest comes with loss or reduction in the number and types of plant and animal species, otherwise called as biodiversity loss. Loss of biodiversity is caused by changes in temperature, air quality, water quality, and increasing incidences of drought and extreme events. Next slide. Increasing numbers of studies have been completed and or are currently ongoing to investigate the impacts of climate change on biodiversity. To mitigate biodiversity loss resulting from climate change, Canada has established domestic and biodiversity goals that include conserving a quarter of Canada's lands and a quarter of its oceans by 2025. Next slide. Climate change is affecting human health and well-being, and this figure illustrates the direct and indirect effects of a changing climate on human health. Rising temperature results in increases in heat, severe weather, and air pollution, which in turn are associated with increasing incidences of heat stress, cardiovascular failure, injuries and fatalities, and respiratory problems such as asthma, chronic obstructive pulmonary disease or COPD, allergies, and respiratory cardiovascular disease. Increased temperatures result in higher frequencies of wildfires, which contribute to air pollution and smoke. Weather extremes, such as higher frequencies of flooding, results in increases in vector-borne diseases, allergies, and waterborne diseases. Climate change is expected to increase the geographic range of insect disease vectors, increasing health risk. With the warming climate, Lyme disease vectors are establishing themselves in larger areas of Canada. It is estimated that 80% of eastern Canada's population are already living in areas where tick populations have established themselves. Rising sea levels result in increases in environmental refugees as people are displaced. Increasing flooding has resulted in exposures to sewage and waterborne diseases, exposures to mold, and reduction in food and clean water supply. Next slide. Climate change vulnerability and adaptation assessments have many elements in common with other types of assessment, including human and ecological risk assessments. While there are many steps that are familiar, there's also elements where they differ and will require a different approach. Given this, climate considerations can be incorporated into the conduct of human and ecological risk assessments to identify climate and health risk drivers. By doing so, climate considerations are incorporated into risk management and planning, thus building climate resilience. The slide provides an example of a climate risk map that identifies climate drivers such as heat, air quality, flooding, vector-borne disease, waterborne infections, mental health and well-being, exposure sensitivity, and other health outcomes. For example, rising temperatures will lead to an increase in heat-related deaths and illnesses. Climate change vulnerability and adaptation assessments are typically completed evaluating a range of study areas from local to national scales to understand current health impacts and projected future health risks, and to identify adaptation options to increase resilience to these climate risks. Next slide. This slide pertains to the heat dome event that occurred in British Columbia, Canada, when temperatures hit 30 degrees Celsius or 80 degrees Fahrenheit and higher starting on June 20th through to July 29th. Next slide. This unprecedented temperature increase in British Columbia led to 570 heat-related deaths, primarily in the elderly, those older than 70 years of age. Most deaths occurred in private residences, in areas with less green space, more people living alone, and lower income levels. As a result of the event, the province of British Columbia is taking actions that include installing air conditioning in long-term care facilities, and funding has increased towards improvements in paramedic and ambulatory responses and emergency response. Next slide. This slide illustrates a typical conceptual site model, and in this case, it's for a mine site. Conceptual site models, or CSMs, that support human and ecological risk assessments hinge on source pathway receptor linkages that typically involves identifying sources of chemicals and chemical releases, pathways of releases, and exposure points by which human and ecological receptors can come into contact with site-related chemicals. The findings of a traditional human and ecological risk assessments will identify source pathways that will require mitigation or engineering controls to mitigate health risks to human and ecological receptors. These CSMs can be expanded to incorporate climate change trends in the form of changes in air quality, water quality, and biodiversity as a result of project contributions to the environment. For example, I've been involved in evaluating changes in air quality and impact to human health as a result of climate change during the life of a proposed mining project. This was part of a mine development of a mine closure plan. As well, I have evaluated the impacts of climate change and potential discharge of impacted surface water resulting from climate scenario of a dam failure and projected increased flooding. This climate scenario evaluated potential impact to water quality and receiving water used as drinking water as well as recreational purposes. For more on the assessment method, I will turn the presentation over to Sean. Sean?
Thanks, Teresa. I'm really excited to present to my new WSP colleagues, and I am really looking forward to further collaboration on these types of projects and other climate change risk assessments. I'm going to continue to use mining as a case study using Teresa's example, but I think it's important to stress that these approaches can be used and must be used for all sectors and all projects where we're looking at incorporating resilience. And this is really important that we incorporate human health and ecological risk assessment as part of Future Ready. And the challenge that we have is to move from a qualitative assessment to much more of a quantitative assessment using this conceptual site model that Teresa has outlined. So what are the challenges? In the past, it's been data and process. So let me cover the data now. The ability to project climate change on a very granular level has increased significantly over time. And the science behind that has been supported by the Intergovernmental Panel on Climate Change as they release their assessment reports. The 6th assessment report was just released in August, and it provides the physical science to this changing climate and is the data that supports the projections that are available from the Canadian Centre for Climate Services that Teresa mentioned, or any number of data portals globally. So now we have the ability to get the detailed information on the climate projections and apply them at a granular level to this conceptual site model. And we're doing that already when it comes to other physical models such as hydrology, and we can provide that data in a way that can fit into colleagues' data. So the other challenge is process. So we can build off the significant experience that we have right now in terms of looking at physical risk assessment on infrastructure. So WSP and Golder have tremendous experience looking at how climate can affect buildings, mines, depositories. And so that process looking at the physical risks, the hydrology, for example, the amount of water, needs to be applied to these human health and ecological risk assessments. And it's the same approach of using the likelihood, the probability of a climate event occurring, what is the consequence of that happening in terms of health impacts, and then what the risk is. And so this process can be adapted to the conceptual site models and human health ecological risk assessments. So again, using mining as an example, I have extracted the stage-wise process from the Mining Association of Canada's climate change guidance. So the reason I'm pulling this out is, again, to show how this can be applied to all sectors. In our experience, mining has been asked to look at this climate change risk in through a number of different venues. The funding requirements under the IFC or Equator Principles from banks, under various environmental, social, social impact assessment frameworks to say, how are you incorporating climate and making sure that the project is resilient. And climate and mining has always had a large social and ecological component to these ESIAs. So that's how these considerations were incorporated in this process. And the Mining Association of Canada process stresses the need to look at how climate change can not just affect the infrastructure of the mine, but how the mine is going to interact with communities, looking at water security long-term, looking at human health impacts long-term, and the ecological component. The other thing that the guidance does is it talks about this concept of developing adaptation pathways, so that you do not have to answer all the questions now in the first phase of the risk assessment. It becomes a continual improvement process where these processes are refined over time, and you have options moving forward. And so let me show that in, I think, a graphical way to show that this is very appropriate when we're dealing with long-term planning for communities or cities or larger infrastructure, that there may be different thresholds or triggers that Teresa talked about that could be passed over time. And so what this figure shows is the representative concentration pathways from AR5 and extended concentration pathways beyond the end of this century. And there is a significant difference in terms of what the future could be. And that will be aided as part of COP26 in Glasgow at the end of this year, in terms of which concentration pathway the world is going to be likely to do. But right now, all of those are equal probability in terms of what the IPC says. And we need to then have options for increased heat, for example, if GHGs cannot be controlled. And so this options is set out in this figure as well, showing how there may be some actions that could be taken in the short term that is going to provide resiliency now and in the long term, or there may be an acceptable risk now and in the long term that's shown by this conceptual site model, the human health and ecological risk assessment, or more likely there'll be these different triggers that have to be set to take action in the future to prevent the outcomes that Teresa talked about. So let me talk about two examples where Golder was involved in mining. The first one is in, again, guidance, closure guidance. The process for closure is considered at the pre-feasibility stage or at the earliest stage of planning a mine. So the operators have to consider closure as they are going through the construction and initial design of the process. And that's outlined in this mine closure checklist for the Asia Pacific Economic Cooperation. And it mandates this type of assessment process for the human health and ecological risk assessment, and says you have to consider climate change. And so now it's making sure that we've got the examples and are considering that on this detailed quantitative basis. The next example is on biodiversity. So here, we've been working with Teck Resources for a number of years. Teck has an ambitious sustainability plan, and they want to achieve a net positive impact on biodiversities where they're operating. So they're not just looking at no net loss, they're looking at improving the biodiversity around the areas where they operate. So we have helped them in looking at baseline data, environmental assessment, how the reclamation and closure can be planned and implemented, and looking at how the species at risks and other populations can be improved. And key to that is looking at how climate is changing in the short term and in the long term. We focused on risks from climate change, but here's an example of opportunities. Under a changing climate, there may be different growing seasons promote different patterns, and the reclamation can take place faster or in a greater diversity than if we didn't know what the projections were. And it's that baseline assessment that is really important to understand what is the effect of the project on biodiversity and how climate change is affecting that as well. So I'll leave you in summary. We can and must consider human health and ecological risk assessments in the same way that we're doing physical risk assessments in a detailed quantitative approach, linking into the conceptual site model and ecological risk assessments and being able to provide this data. It's going to improve our baseline. It's going to help us understand the variability in health outcomes. It will better prevent future ecological health risks and take opportunities of different climate conditions. And the most important thing is it's going to, prevent or reduce these future risks that Teresa outlined, where it really is affecting the most vulnerable and sensitive members of our population, and we need to be able to protect them. So I will close that, and we can turn it over to questions and answers.
Thank you, Sean and Teresa, for a fantastic presentation. Before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform, and also you can download a PDF version of the presentation from the handout box on the dashboard. It would be great if you can open your webcam, please. Thank you. I will start with the first question. Can the approach you have discussed be applied to contaminated sites to assess how climate change can impact long-term risk management measures?
Yes, it can. I'll start, Sean, and please jump in. We are actually starting to ask those questions currently with some of our projects, but I think it's, as Sean mentioned, it's really important to start asking, is my project vulnerable? Is it in an area where it's prone to increased flooding, or do we need to consider increasing in temperature? I think we're only asking part of the question, and it's really important to take a look at a big picture in terms of projecting climate change trends with respect to your project, because I think it does affect, is your engineering control that we've implemented for the contaminated sites adequately protective to mitigate any extreme events that could happen, or any changes in sort of what is natural environment to the project. Sean?
Yeah, and I think, Teresa, you're absolutely right. Being able to take those projections and then change the risk assessment and do this type of a risk analysis of if increased precipitation eroded one of the barriers, how would that change the health outcomes? That's the questions that I think stakeholders want to know, is what is the uncertainty of a changing climate? And we do have a lot of examples of how we've done that already in other sectors. So it is the next step, I think, in a lot of our contaminated sites work.
Thank you. The next question is, if property owners have not considered climate change consideration and the impact on long-term risk management measures, what can they do to start this process?
Do you want to take that, Sean?
Sure.
I can jump.
I think the first thing is to look at the physical risks. There's a clear requirement from many stakeholders and investors to say, are they looking at building a piece of infrastructure that is going to be resilient in the long term? So if you haven't started there, then that's probably the first thing to do. But then it's important to expand that beyond the physical risks we talked about it, and include how that infrastructure is part of the larger environment, whether it's a piece of transportation infrastructure or a building within a community. It's important to look at how that interacts with other stakeholders and use the examples that you've given, Teresa, in terms of how you can look at changes in risk assessment.
No, I agree, and I'd just like to add that in some locations, for example, if we look at some of the extreme events that's happened already, Fort McMurray is a really great example of a wildfire that lasted for 3 weeks, and you have several communities that people aren't able to go back to their homes because post-wildfire situations, they have apparently very high dioxin levels in their homes. So I think in terms of starting now, asking the question, are the industries located in areas that are maybe too close to residents? Should there be buffer areas in the development to um, protect for a case of extreme event? For example, above ground storage tanks, underground storage tanks, should there be secondary containment, and where are they placed? The flooding in Texas is another example where you've got refineries in the state, and in the situation of flooding, then you've got the release of chemicals and whatnot in the water, and people being exposed as they're wading through the water and trying to evacuate. So these are types of, I think, scenarios where we can learn from, where we can start to ask the questions for our specific project in terms of scoping. What is the baseline condition now, and trying to understand that now. How is the baseline changing in the future? I think that would be the recommendation.
Thank you. We'll take the last question. There is a question here about HHERA. It goes like this. HHERA has traditionally been a deterministic assessment. For example, air aquatic concentrations against risk thresholds. Are there challenges integrating likelihood and consequence probabilistic risk assessment model as Sean presented in the HHERA?
Yes, and
Yes.
thank you. Sorry, go
Yeah.
ahead, Sean. Sure, go ahead.
Sorry. So I'll let you finish this, but I think this is, again, building on the challenges and the successes that we've had in other risk assessments, climate change risk assessments. This idea of deterministic or stationary design really is not the level of care anymore when we're looking at physical infrastructure. So just assuming that the rainfall patterns are not going to change is no longer considered acceptable. So moving from deterministic into a stochastic or an uncertain approach is a risk assessment, using risk to deal with the uncertainty. And so, being able to say that there's a range of projections in the future, that we've got to deal with that, very much fits in the risk assessment framework that Teresa will talk about.
No, I thank you, Sean, for that. And I agree. I think Sean mentioned in his presentation that you can start the human and ecological risk assessment based on a certain climate scenario, and you don't have to evaluate all of them. We can handle a certain number of climate risk scenarios that could be incorporated in the assessment using a stochastic approach. And then you just kind of evaluate that as data comes in. As you get more refined data, you can keep this assessment sort of refining this assessment as you get more data. But it is a challenging assessment because climate is changing, and it's changing for some areas quite quickly. And so yes, we have to progress the assessment to be more stochastic, more probabilistic. Communication is going to be challenging. Reporting is going to be challenging. But yes, it does need to progress.
Yeah, and that's the continual improvement process that we talked about. Is as you gain more information, you're looking at that. And we have lots of good examples that we could spend more time talking about, where, in the hydrology world, where we've used probabilistic models to look at water balance using a probabilistic tool like GoldSim that could be very much incorporated in a human health and ecological risk assessment.
Fantastic, thank you. So we're at the end of our webinar session, so please feel free to follow up directly with Sean and Teresa via the contact details shown on the screen. And I would like to thank all attendees for joining today. Thank you for your time, and thank you, Sean and Teresa, for a fantastic presentation.
Thank
you.
you.